Hello, this is the second part of the record of OP part 2. So we will continue with multiple inheritance, and here in the real world, at a real university, the divisions between staff and student and administrative and teaching staff are not always clear cut because some students may be tutors of some courses, or a staff member can also enroll in a course, or a staff member can have both an administrative role in the department and also a teaching position. So in Python, it's possible for a class to inherit from multiple other classes. We could, for example, create a class called tutor, which inherits from both student and staff member. Things get complicated if two parent classes implement the same method or attribute, like if class B and C inherit from A and class D inherit from B and C, and both B and C have a method do something. Which do something will D inherit? And uh, so let's see the diagram. Here we have multi-derived, which can be derived from parent 1, which is base 1, and parent 2, which is base 2. And suppose that both parents have the same method or have the same attribute, then which method or which attribute that class that inherit from two parents should do. Then fortunately, the super functions know how to deal graceful- gracefully with multiple inheritance. In addition to saving keystroke of referencing the different parent class name, there are no benefit of to using super with multi inheritance patterns. In short, if you are going to use multi per inheritance, use super. Okay, so let's see the demo code here. So here we have class stationery, which has the ini method, and has class pen, which inherit from stationery, right? And class pen also called the ini method of superclass, which the class stationery. And here we also have class pencil at line number 13, which is also a subclass of class stationery. And here we have the ini method, which also called the ini method of the superclass of pencil, uh, which is the ini method of stationery. And here at line number 11, 21, we create the object pen. And the object pen here has the name as my pen 1, right? And has the color as blue, and has the pencil as black, and uh, it also has the okay, so pencil here, uh we want to say that black is actually like the color, right? But here, uh when we print it out, it also indicate that my pen 1 has color as blue, and my pen seal 1 has color as black. And this here, uh, pen accept name and color, right? And pencil accept black is the color. And then other arguments, and here other arguments are like name, right? So that's why when we print it out, we have as the correct information. Okay, so uh here we let's see another demo problem. Here we have class circle. that extend from shape, and class circle has its own private attribute radius. And here we want to define the method get radius of class per circle and set radius of class circle. In addition, class circle also has the method get area. And here we want to override the ini method so that we can create the circle object which has the default value as the default color as yellow. And we override the method string so that when we print the circle object, it print out that this circle has radius as the radius value and has area as the area. Okay, so this the output that we want to have. Here we create the object circle which the radius as 4, and then we print that this circle has area has, and then call the method get area with two floating point. And if we just print the object circle itself, it will return the string that display that this circle has radius as 4 and color as yellow and has area as 50.27. Here, super alone return a temporary object of the superclass and then allow you to call the superclass method. Calling the previously built method with super save you from needing to rewrite those methods in your subclass and allow you to swap out superclass with minimal code change. Uh, Inheritance is a concept in object-oriented programming in which a class derives attributes and behavior from another class without needing to implement the code in the superclass again. So here we have class rectangle that has attribute length and width, and the method area return the value of length multiplied with width, and method perimeter return 2 multiplied with length plus 2 multiplied with width. And for the class square, we initialize it with accept the length and define the area as length multiplied with length, perimeter as 4 multiplied with cell dot length. And here we get the correct result, but you can observe that actually rectangle and square are related, right? Because a square is a special kind of rectangle, and this code, however, doesn't reflect the relationship between square and rectangle. And cause you can see that there are code that repeated. But if we use inheritance, we can reduce the amount of code that we need to write and reflect the relationship between rectangles and square. So instead of define those class separately independently without reflecting the relationship between superclass and subclass, now we define class as rectangle uh, as before, but here in class square at line number 13, we specify that class square is a subclass of rectangle. And then in the ini method, we just call the ini method of rectangle with the parameter length and width as length. And then we get the same result but with much shorter code. We don't need to define area and perimeter of square because it just use the same formula as uh, computing area and computing perimeter of rectangle. So let's see the code explanation. Here rectangle is superclass and square is subclass. And because square and rectangle in method are so similar, so you can simply call superclass in method and rectangle in method that of square by using super. And this set the length and width attribute even though you just have to supply a single length parameter to the square constructor. And we actually can go further, like class cube is also special type of like square because like it actually like just square multiplied with another dimension of length, right? And here we class Q will have specialized method of its own class, like compute the surface area and compute the volume. So here in class square, we create the object class square, and when we print out the area, we get 16. And here we can also create the object of rectangle, and when we print out the area, we get 8. And for Q3, when we print out the surface area, uh, we get 54, because here in the surface area is actually called the area of each uh, face, but it has six faces, so it's return 6 multiplied with face area, and that's why we get 54 here. And for volume, it will be face area multiplied with cell dot length, and uh, face area is 9, right? And length is also is 3, so that's why we get 27. So in Python 3, the super square cell call is equivalent to the parameterless superclass. The first parameter refers to the subclass square, while the second parameter refers to the square object, which in case is cell. So you call super with other classes as well. Now, Python supports multiple inheritance in which a subclass can inherit from multiple superclass that doesn't necessarily inherit from each other. Like here, we can see that subclass here can inherit from superclass 1 and can inherit from superclass 2. Then there can be problem, right? Here we have a class triangle that accept parameter base and height, and the area is 2.5 multiplied with base and height. And here we have class right pyramid, which inherit from triangle and square. And then in the init, we initialize base and slant height. And in the area, we call the method area of superclass and call the method area of perimeter. And then the area of line parameter is 0.5 multiplied with perimeter and multiplied with slant height plus base area. And then we create the object of right pyramid and print the area. And now we can see the problem that when it try to compute the area of pyramid, it's actually will go to compute the area, right? And here the area try to compute by return 0.5 multiplied with base and height, but here um, it doesn't have the attribute height, uh, so there's the problem here because when we uh, initialize the right pyramid, we actually use slant height, not height, right? So let's see the explanation of the problem. The problem here is that the interpreter is searching for area in triangle before square and rectangle. So upon finding area in triangle, Python call it instead of one you want, because triangle area expect that there should be high attribute. So that's why Python throw attribute error. So if we want to solve the problem, then we need to use method resolution order or MRO. MRO will tell Python how to search for inherited method. This come in handy when you are using Super because MRO tell you exactly where Python will look for a method you are calling with Super and in what order. So by changing the signature of right pyramid class, you can search in the order that you want. So in right pyramid, we will specify that we uh, want it to uh, search the area from square first and then triangle. So now the area will go to find go to call the area of square which has height, right? And so uh, then there won't be the problem as before, and this area will use length of the object. But before there's the problem because here we say right pyramid, triangle and square, but here we specify right pyramid, square and triangle. So in this case, if square and triangle have area method, if you call the method area of square first. Okay, let's see the last topic, which is polymorphism. Polymorphism is taken from the Greek words. Poly means many and morphism means forms. So it means that the same function name can be used for different types, and this makes programming more intuitive and easier. Polymorphism in Python allow us to define method in the child class with the same name as defined in their parent class. Okay, we can see the built-in polymorphic function, right? If you use len with string, it actually compute the number of characters in string, right? So that's why here it return 5. But if we use len function with list, it actually return 3 because this list has 3 members. So you can see that here we have the same function name, right? Len, len. But then if we apply for string, it will return the number of characters. But if we call it with the object list, it will return the number of members in the list. So that's the idea of polymorphic functions. Same name, but when applied with different objects, if you do different things, if you do it appropriately with that kind of object. So we can use the concept of polymorphism while creating class method, as Python allows different class to have method with the same name. We can then later generalize calling this method by disregarding the object we are working with. Okay, so let's see the example here. Here we have class cat, and class cat has method ini, info, make sound. And we also have class dog, which has the method ini, info, and make sound as well. And then later we create the object of class cat and dog, and we put them in tuples. And here we can use for loop to call the object, to call the function info and make sound of each object in a tuple. And we can observe that even though with the same function name info or make sound, but when pet is cat, it will return as I am a cat, my name is Kitty, I'm 2.5 years old. And when we call the method make sound of cat, it will say meow. But if we uh, call the method info of dog, it will say I am a dog, my name is Tongdi, I'm 4 years old. And if we call the method make sound of dog, it will uh, print out bark. So here with different kinds of object, uh, cat and dog, even though with the same function name, it will add uh, differently depends on the type of the object. So like in other programming languages, the child class in Python also inherit methods and attributes from the parent class. We can redefine certain methods and attributes specifically to fit the child class, which known as method overriding. Polymorphism allows us to access overridden methods and attributes that have the same name as the parent class. So here we have shape as the parent class, which has the method string and fact, and we have square and circle, which are children of shape. And here in the main method, uh, when we say print b, and we call b dot fact, we will call fact of shape. Uh, if we have a dot fact, it will call the fact of a, and uh, if we call area, it will call the area of that object. But here, fact of square here will actually call the method fact of its own class, not its parent. It won't use the fact of square if square has its own fact method. Okay, so let's see the example here. Here we have class shape. We have the area method, fact method, and the string method. Square is a subclass of shape. It has its own area and fact method. And we also have the class circle, which also subclass of shape. It also has the area method. And here in the main method, we create the object of square, uh, and we create the object of circle. When we print b, b is the object of circle. Then if you go to class circle and find that it doesn't have a string method, so it will call the string method of its parent class, which is shape. So when we go to class shape, uh, in the string method, it return name, the class name, right? Uh, the name that it passed to. So here, that's why the first print out here is circle, because here is simply just print out its own name. Okay. Okay, so and here at line number 31, in the class circle, in the ini method, we initialize name with circle when we call the ini method of shape. So that's why we have circle as the first output, because circle object here has name as circle. Okay, so let's see the next statement at line 41. We print b dot fact. So circle also doesn't have a fact function. So it will call fact function of shape. And fact function of shape just return string I am a two-dimensional shape. So that's why we see the print out I am a two-dimensional shape here. Okay, and then at line number 42, we execute the statement a dot fact. So here a is square. Square has its own fact, which return square have each angle equal to 90 degrees. So if you execute fact in class square, not execute fact in class shape, because class square also has its own fact. So that's why we see the third output as square have each angle as 90 degrees. And then when we call the area of B, uh, it return that the area itself is from the computation pi multiply with uh, radius and multiply with radius itself. Okay, so I hope that you understand about polymorphism and inheritance. If the class has its own method, it will call its own method. But if it doesn't have that method, we'll look at superclass, which whether the superclass has that method. If superclass has that method, then it will call the method of that superclass. Okay, and these are the reference of the content of this slide. So I hope that you understand about how to print the object by defining the string method, the encapsulation via the setter getter method for the private attributes, and the inheritance concept where we can reuse the code, and the polymorphism with the same function name, but it can act differently, depends on the type of the object that we call that method. Thank you.